I'd like to welcome you to Criterium Engineers. This is the webinar for residential solar PV systems, which I first did on March 2nd of 2020, and we're re-recording it for you so that it's much clearer and doesn't have all the noise in the background. My name is Helen Watts. I'm a PE in Maine, Massachusetts, New Hampshire, Hawaii, and Colorado. I am a senior structural engineer in the Freeport office. My office number and my cell number are attached. And before I get to that, let's just talk about what we're going to talk about here. This is about residential solar. I want to talk about why there are suddenly so many installations going on, what's changed. I want to talk about what new improvements are hopefully expected, where those new improvements will come. Then I want to talk about what happens when you put solar on residential roofs and what design information is important. I want to talk about snow and uplift. I'd like to talk about durability, concerns, problems, battery systems. And then I want to talk about the fire department concerns because they have some. So this is what solar panels have done. They've become much more efficient. As that's happened, and this is 1960, and this is pretty much now, we've gotten a whole lot more efficient. How efficient? It's not at 90%. They're at 20% perhaps, and there's rumors of 45%, which would be another jog upwards. So there is more room possibly here. That's not where we're looking for it. Here's the cost benchmark summary. Residential power is different than commercial power, is different than utility scale power. And I want to stick with residential. This is where we were in 2010, and this is where we are right now. And this number, if you can see it, is $7.34 per kilowatt hour. And we're now at, or we were in 2018, at $2.70. So it's 2.5 times less than it was in 2010. So whatever information that you have, if it's from 2010, that's old news. The solar investment tax credit is still in effect. There is an investment tax credit that is still available. The investment tax credit at this point is not the fiscal incentive that it was before. Oops, sorry about that. There's another table from the Solar Energy Industries Association, the number of U.S. solar installations. And here they had a little setback because of tariffs and reductions in solar incentives, and people were just discouraged from going and installing solar. That lid has been taken off. 2019 is much higher than this. This was just an early number for 2019. So here's the historical and projected photovoltaics, and yeah, shooting right up there. Is this what's happening? Well, this is the day. This is the time at which this graph was built, and yes, it is actually doing this. We had a couple of years right here that were low, but these years are much higher actually than that number. The cost trend. So here we are in 1998. it was $12 per kilowatt, and now we're down here, and residential is the green line. We're about at $4 for the residential. So solar PV systems, they cost less than residential delivered power on a 25-year basis, and the photovoltaic will last longer than 25 years. So this is kinder to the standard central Maine power type of delivered power than it is to the solar panels. We are cheaper than residential power in all 50 states, not just Hawaii and Puerto Rico, but as of 2016. And the price has continued to go down. We're 4 years beyond 2016. How cool is that? The cost may have bottomed out for the solar panels, and I'm only saying this because we bought our panels last October, so that would be 2019, and they told me that the price had actually squeaked up just a little bit, but because they liked the structural engineer who was doing their letters, saying that their solar panels wouldn't break the roofs they were being installed on. They gave me the lower price, not the higher price. So the cost may have bottomed out a bit. It's not in free fall plummet. Opportunities. The opportunities for cost reduction, for improvement in durability, how much depth of charge, how much power they put out, battery systems. The Tesla Powerwall is the one that we were looking at for our home. The inverter life and the inverter cost. The life is currently about 12 years, about like a hot water heater. They're looking at stretching out the life of the inverter. Another opportunity, car chargers. Car chargers are going to be a huge part of what we're doing in 10 years. And if we're ready for them, all the better. Let's talk about how we go about getting solar panels on roofs. The snow loads are found at this location, hazards at atcouncil.org. It's free. You input the town, and they'll give you the wind, they'll give you the snow, they'll give you the seismic, they'll give you the wind for a particular building code. Wonderful thing. This is the numbers that make up the maps that are in the ASCE 7. So this is better data than you can guesstimate off of trying to figure out where the county lines are in the ASCE 7 maps. All right, the roof snow load is different than the ground snow load. I get this. Carpenters all the time have trouble with this. Oh, well, aren't I supposed to be using 80 pounds per square foot? No. The roof snow load is going to have a bunch of factors put into it. The first factor is 0.7 for it being on a roof. And this means that the wind can blow the snow off the roof. Not all the snow will land on the roof. Not all the snow will stay on the roof. So the roof factor, 0.7. The insulation factor, I've been using one my entire career. For insulation that meets the current energy code, which would be enough to meet the code, 1.1. So you bump things up a little bit because you're not melting the snow off of the roof. If it's really well insulated, really well air sealed, go 1.2, because you're not going to melt any snow off the roof. It's just going to be just as cold as, the neighboring barn. And then there's the slippery factor. Solar panels are slippery, just like metal roofs. If you get a slippery roof, you multiply your other factors in your ground snow load by 0.7. Presto, as soon as you do that, you've added a dead load onto your roof of 2.7 or 2.8 for a system that's run pretty snug up against the roof panels. If your ground snow load is 20 PSF or more, the addition of the slippery surface more than offsets the weight of the PV system. So if you've got an existing roof and it's got asphalt shingles, you're going to have a lower load on the roof, on that side of the roof, because you've got less design weight total. It's a lower snow load plus a slightly higher dead load, and you're better off. All right, now let's talk about wind. When you look at wind in the ASCE 7, the corners and edges of the roof have higher wind load. The corners have a double higher wind load because they're getting wind from two sides. So you want to keep your panels away from the edges of the roof. You certainly don't want them overhanging the edge of the roof, and people have suggested that. That's not a good idea. The PV system attachment to the roof is usually by the system manufacturer. So they're going to go and connect the PV system to the roof. Durability. The panels should last 40 years, maybe more. The roof they should be installed on should be new. We didn't install our panels on our roof until a couple of years after we'd installed the standing seam coated metal roofing, which is a 40-year roof. If you've only got 5 years left in your roof shingles, replace your roofing and then go and replace your solar panels. Oh, other concerns. Add snow guards at the eaves above doors, decks, and balconies. There's this tremendous whoomph noise, and then the cat runs and jumps. Yeah, hopefully not on you. Claws, you know, blood. So you add snow guards at the eaves, and it will hold the snow in place so that it can just melt off the edge instead of coming off and putting a huge impact load on a balcony or a deck, which might have ledger board problems that you don't know about. And then there's people coming out of doors. In Maine, people get killed every once in a while in the wintertime. They're underneath the eaves of a building, and a bunch of snow lets go from the roof. Whoomp. And it compacts. It's a lot of weight, fast, hard. We don't want any of those things happening at the underside of our wonderful solar panels. Unbalanced loads. I want to fix any visible roofing elements. If you've got cracked rafters, then I want to sister up those rafters and make sure that I've got enough strength in my rafters. If I can see that there are no ridge ties and they're needed, I'm going to go and add the ridge ties. If there aren't any eaves ties, I'm going to see if there's any way I can get away with them without having an eaves tie. Otherwise, I'm going to make sure I've got some kind of an eaves tie. So it's a connection down at the eaves. So I've checked for spreading up at the ridge, and I've checked for spreading down at the eaves. Battery systems. And we were looking at battery systems, and they were talking about $10,000 for the Watts household for batteries. That isn't the year quite yet. The Tesla Powerwall, for a system that would give us a good start, probably $15,000. For a system that would run our well pump, $22,000. And you know that amount is going to include the piece of equipment that goes between where the power comes into the house and the meter. It would include a smart panel that would decide to possibly shut off or turn on some of the electrical systems in the house. And it would include the power wall. So there's kind of three pieces to that battery. There is still a 26% federal incentive for that, which for $22,000 worth of panels would be $57.60. So, you know, $5,000, you'd end up paying another $17,000 for your battery system. Hail conditions. And I actually got this from my daughter who lives in Colorado. They had a Colorado roof, 3,000 panels on a commercial installation. They had a massive hailstorm and they had to replace one panel, which is I think that's a tremendous number. So these solar panels are actually protecting some of these Colorado roofs. And the roof that gets damaged underneath the panel, you take the panels off, you fix the roof, you put the panels back on. That's the method. Fire department concerns. Fire chief wants a 3-foot space at the edges of all the gables and the ridge, and for walking up, for walking up the gable, and then to go and poke holes in the ridge. The solar installers think this takes up too much roof real estate. And really, if you think about it, I would rather they poked holes on the north side of the ridge instead of the south side of the ridge, and that's usually an option. Just seems reasonable. So the code battle is being engaged. And the fire chiefs are on one side, the solar installers and people who don't have a lot of roof real estate are on the other side. So that's a fast blast for the solar panels on residential roofs. If you have any questions, please call me at 207-522-9366 or give me an email at Helen Watts at criteriumengineers.com. Thank you very much.